back again. This is Choir for Tech Lab channel. We are back with another lab configuration where we actually will be dealing with the first hop redundancy protocol. In this case, we will be beginning from hot standby router protocol or HSRP. We will also move to VRRP and we will also go to GLPP. So basically what we're doing right now, we are utilizing two routers. As you can see, we have two routers directly connected to the WAN connection to the internet, as you can see, and we have the switch that connects our local area network, which is this PC, which is running suppose it's running any operating system, and then we have these network IDs that we'll be using, this IP address that we'll be using on our configuration. Okay, the most important about the host and by router protocol, it allows us to have a failover mechanism on the network configuration. So we have a router that is responsible to forward traffic and being active on the network. All the packets or all the frame they pass to that router, it's active, and then we have another one which is standby, just in case if the active router fails. The standby will have the same capabilities of routing the packets as much as the active router was doing it. Okay, so as you can see here, we have that active router on the left hand side, and then we have the standby router on the right hand side. Now the question comes, how does these routers, or how does the network decide which router is actually responsible for being an active router and which one is also responsible for being a standby router? Okay, so we're just gonna deal with the configuration and see all of those configuration being done on this lab. But what is most important is that this is determined based on the priority and the IP address itself. The higher IP address, it always win, and also the higher priority always win. The default priority of the HSRP or the standby is actually 100. So if we can configure one of these routers as the highest priority or the higher priority more than 100, which means that router will be elected as the active router, which means if we set this router as 110 instead of 100, which is set as default on the HSRP, that means this router will be an active router that forward the traffic to the internet. Okay, something else that we also need to look at too, let's say we have two routers, they are not manually configured with the priority, so that means they will both have 100, then that's where the IP address will be looked into, and the higher IP address will be obviously the one that will be an active router. Okay, so we need also to configure something called the visual router as the router that will be handling all of those traffic. Okay, so this is going to be our IP address of the visual router that we'll configure here in both of these routers. As a result, this is going to be the default gateway of this local area network over here. Okay, so this local area network will try to reach out to that visual router IP to go to the internet, because if we can use the local IP address as the default gateway of this local area network, that means if we try to send a packet and this interface is down, it will be not reachable to the internet, or the internet will actually not work for us in a local area network or in this segment. The packet will be dropped as soon as it touches that default gateway that we utilize on the local area network, or local area network, which is why we'll be using this visual IP address, because it will be configured as standby IP address on both routers. So if this one goes down, this one will take the exact functionality that was assigned on this one, and this one will be active. But we're gonna see that happening right now as we do all of the configuration on this lab. Okay, so let's start by switching on all of our devices. This is a layer 2 switch that we're using here, and then these are the layer 3 devices. Okay, so while waiting for this switch to come out, let's just select this router. I'm just gonna go to another router as well and do the same thing. While we're waiting for them, let's go to this switch. Let me try to put everything together. Let me see if I can go to the other one as well. Let's see if we can go to the switch itself. Okay, let's give it some time. Here we go. This is router 2, by the way. The one that we gonna configure is our standby router, but we will see the failover actually happening, and we will set the timers. Again, we have two versions. We have version 1 and we have version 2. Okay, version 1 have limited things that we can actually do, such as the timers. We can actually determine the hello timers and the hold timers. By default on version 1 we have hello timers set to 3 and we have hold timers set to 10. In that case, those are in seconds, so if we can try to maybe minimize the time it takes for the changeover to happen on this network, we will have to go into milliseconds, and then we will have to maybe reduce it to 15 milliseconds, and then we can go to 50 as our milliseconds in hold timers. But that we will have to be actually be able to do on HSRP version 2. Okay, and the MAC addresses that are actually utilized by the visual IP or on these on this both version, which is version 1 and version 2, they are actually different, but we will see that now shortly as we do the configuration. Let's start by configure this router over here. All we have to do is to come here and type the command config terminal, and then from here what we can do is assign the IP address as normal. So all we have to do is to navigate to these interfaces. I'm just gonna start by assigning the IP address on this interface. I'm just gonna say this is actually the interface that I'm willing to configure, which is gigabit 0/0, and then I want to assign the IP address dynamically. Okay, DHCP, and then I want to hook this interface up. Okay, the interface will go up, and then also I will receive that DHCP IP address list from the DHCP server. Of course, if you haven't read about how the DHCP works, you will have to go back and look for the videos that actually took more based on the DHCP server. How is it leasing the IP address, how the client actually discover the server, and also how the server offer and to the client, send an offer to the client, and then the client send the request and then get acknowledgement from the server. Okay, so while we're there, let's just set the description link. This is the link to WAN interface, and then let's just come out. Okay, let's select another interface, which is gig 0/1. This is the interface that I'm currently configuring. As you can see, I'll use this IP address of IP 10.10.10.2, and then I'll just use class C IP address or subnet mask, and then I'll just say no shut. Okay, let me wait for the interface to actually come up, and then I will just set this description a link to the LAN. Okay, exit, do right. Now let's move to router 2 and try to do the same configuration so that we do everything once and for all. config terminal. This is the route that I'm dealing with now, the second route over there. Let me try to put this down. I'll try to move this up a bit, and then so I'm trying to configure this interface. I'll just say interface gig 0/0 IP at DHCP. Okay, and then from here I'll just say no shutdown, because by default the layer 3 interfaces, they are on a shutdown state, so we need to hook them up. Unlike the switch, the layer 2 switch, by default all of the interface or the collision domains, they are actually up, so there is no need for us to run no shutdown in all of those ports that are on the switch. Okay, so what we have to actually do now, we need to select the other interface, interface gig 0/1. This is the interface I'm talking about, and then we need to assign the IP address, which is 10.10.10.3, and I will use the subnet mask of class C IP addressing .0, and then we say no shutdown. Okay, the interface will also go up. Okay, as you can see, the status have been changed to up. Alright, we still are gonna talk more based on how to track the line protocol on the router, especially for this interface over here, because we actually want to ensure that the packet, when it's being sent over the internet, as soon as that interface is actually down, the priority of this router must be reduced, so it must decrement with the priority that is actually less than this router, so that this router will go down and won't be the preferred active router on this network. Alright, so the packet will just go to this standby, that change its state from standby to active after we set the tracking of this interface, that as soon as it's changed, it must decrement the value of the priority from here. Once the value of the priority have been decremented on this active router, this will have the higher priority, and then as we have the preemption also configured on this router will become the active forwarding route. Okay, it's forwarding the route, it's forwarding routes, so it will be the active router. All right, so that is what we're willing to also do. All right, now let's move on. So let's set this description, and then this is just through a LAN. All right, exit. Okay, now I have actually configured my IP addresses. All now I need to do is I need to actually also configure something called, I'm just gonna utilize the OSPF in this case around. Let me just try to utilize the OSPF routing protocol. Okay, I'm just gonna say router OSPF. Just gonna say this is 10, and then I'll just say router, which is an ID. I'll just say .1.1.1, and then I'll just say exit. And actually I'm on router 2, so I'll just say interface gig 0/0 IP router OSPF, sorry, IP route OS, sorry, IP router. Okay, let's do this. There are so many configurations that are on my mind. Sometimes I just Okay, let's just do this. Let's go back and say interface gigabit 0 slash 0 IP OSP, sorry, OSPF 10 area 0. Sorry about that. We want to associate this interface as part of the IP OSPF 10 area 0, and then we actually want to, we can configure the point to point, but in this case let's just leave it. Let's say interface gigabit 0 slash 1 and then IP OSPF 10 area 0. Okay, so we have associated both of these interfaces part of the OSPF interfaces. So let's just say exit. Okay, let's move to the other router and do the same configuration too. I'm just gonna say router OSPF 10 and then the router ID should be 2.2.2.2, or I can just, yeah, let's just make it 2.2.2 and then we can just exit. Okay, let's select the interfaces that we want to associate with the OSPF. We actually have to type in the command um, area 0 exit interface gigabit 0. Okay, as you can see, they both form the member ship or the neighborhood or the adjacency. So these routers now, they can be able to actually communicate. Alright, so which means if I can have some sort of another interface okay, that is in here, and I can be able to ping that interface as soon as I also introduce that interface as part of the interface that uh, have the OSPF features. Okay, so let's come to interface. Yes, interface gig 0 slash 1 IP OSPF 10 area 0. Okay, exit, do right. Okay, the adjacency has been formed. Now what about that interface there? What else can we do with it? So we can actually try to execute a ping, do ping to 8.8.8.8, which is the internet. First one is dropped. Now let's see the other one. As you can see, we can actually try to ping to the internet successfully, but the question is now, can I be able to ping from this interface, which is gigabit 0 slash 1? So I want to ping now from the specific source, which is 0 slash 1. As you can see, I won't be able to actually ping from that specific um, source. Now what should I do? I need to redistribute traffic or set the default um, information originate on that specific router, and then I will also have to configure the access list to permit the internal traffic to outside. Now what we have to do now, we have to actually go to router OSPF 10. I want to default set the command default information originate. Okay, let's see if we can still be able to ping to the internet. As you can see, we can still be able to ping to the internet. However, when we try to ping from that specific source, let's see what's gonna happen. We still cannot be able to ping from that specific source. Right, but what do we need to do? Like I said, we need to configure some sort of an access list that will allow the traffic from inside to actually goes outside. By typing the command access list, we can use the value from 1 up to 99 because we are actually using the standard access list. The extended uses 100 to 199, and then the list goes on and on and on and on. There is a time when we actually configure something called a time-based access list, where we deny or permit traffic based on the given time. Alright, so let's say we want to use just any simple number. So we're gonna say access list 1. We want to permit not just a single or host or a specific network ID, but let's just permit anything. Okay, permit any, and then let's just come in here and let's give it some time, and then let's come in here and do the configuration, config terminal, and then let's do a ping to 8.8.8 and see if we can still be able to ping. Alright, of course we can be able to ping from that specific interface, but can we still ping from this interface over here? Let's see what's gonna happen. Okay, it looks like we still cannot be able to ping. Let me try to run that ping again. I'll just try to run it maybe at least 5 times to ensure that we cannot be able to ping. Alright, let me just wait for it again, and then I'll run it over again. Okay, to ensure that we cannot be able to ping from that specific interface. Alright, now what I can do is I can configure something called a net IPnet IPnet, and then I can just say IPnet source. Okay, IPnet inside source list 1 interface, in which the interface would be that 0.0/0, and then actually I want to override that interface. I want to overload, sorry, and then I want to select configure, let's say, yes, I want to select that interface which is gigabit 0/0, and then I want to make it as IPnet outside. Okay, let's give it some time. The interface will actually go down, and then let's come here and do the same thing. So in this side, I actually want to do the same thing that I've already done on the other router by uh, selecting that interface as part of the net, which is gigabit 0/0. But first of all, I need to create some sort of an access list, and then this is part of group 1, and then I'll just say permit everything, permit any, and let's see what we can do. And then also I want to configure something called router OSPF 10 default information originate exit IPnet inside source list 1 interface, which is actually gig 0/0 overload. Okay, we're just trying to pretend as if these interfaces, these are having different IP addresses, even though we're using just one uh, internet at the moment, and they are all in the same network range. They have the same public IP, so we're just pretending as if these are two ISPs. Alright, so let's do this. Let's say interface gig 0/0 IPNet outside. Okay, let's wait for that to do its thing. Let's go back to that router over there and see if we can still be able to ping to the internet. Ping, do ping 8.8.8.8. As you can see, we can still be able to ping on that interface, but we cannot actually ping from. As you can see, we can ping now. I thought we cannot because we actually were trying to configure the access list. It didn't work at that time, so it took some time, and then now we can actually go to the internet from that switch. So from this switch we can go to the internet, so we can ping from that device here. This device can have the internet because we have the internet on that interface. Right, this interface decide the rest of the access layer devices here if they can have the internet or not. So as you can see, we can ping successfully to the internet, and we can ping let's see, we can ping Cloudflare, do ping out to 1.1.1.1 from this interface, which is gig 0/1. Okay, as you can see, we can actually ping that. After that, we have configured the NAT rule and also the access list. Alright, now what we are willing to do now, we are willing to dive straight to the point. We're willing to dive to how to configure the standby router protocol. Let me try to clear all this up so that you will see the configuration of the actual standby. Okay, first thing first, I'm just gonna try to verify if we have any standby or active router or HSRP configured on any of these routers. Currently we have nothing. The only way to show it is by typing the command do show standby. Okay, do show. Okay, let's do this. Do show standby. Right, as you can see, we have nothing. Do show standby. We have nothing on both routers. I have no output. Alright, not until I actually configure the standby. Let's start by the router on the left hand side, which is router 1, which we actually want to allow it to be a active router. Alright, and this is gonna be our router when this one goes down. How do we actually do that? So all we have to do, we have to actually go to the router, the one that we want it to be an active router, and then we have to type in the command interface gigabit 0/1. This is the interface that we're willing to actually allow it to be part of the standby. And in that case, I will just say standby. There are groups. I need to allow this specific command or this big specific router configuration as part of group 1, but there are many groups, as you can see. Let's see, we have there are many configuration that we can do, and then we have 0 up to 255 groups that we can actually configure in there. Right, we're gonna configure this preemption, and then we're gonna also configure this priority. We're gonna come to the timers, hello timer and hold timers on version 2 because they actually not work well on version 1, and when we're configuring version 2, we need to specify that now we are configuring HSRP version 2. Unlike on version 1, you can just shoot straight to select the standby and the standby group, and then you can just set the IP as we're doing it now, the IP of the visual router, so which is 10.10.1 slash 24. Okay, but I'm just not gonna put that. It is not necessary, because either way the visual router must be part of the subnet where this interface falls under. Alright, so I'm just gonna press enter. As you can see, we have set our visual router and it's standby, so sooner or later we will see the message that says this router is an actually standby, is a local router, is an active local router, and then we'll see all of those. Something else, if I come in here and say standby 1, I want to set the priority to be okay. As you can see, that message I was talking about, we can see that this router now has become the active router. Alright, so why is it an active router? It's because the other router doesn't have the same configuration that I've done so far. The other router have no HSRP running on it, so this is the only router that has the HSRP configured on it. Remember, we said that by default both routers, they have the same priority value of 100. So let's come in here and try to set the priority. So let's set the priority to be 150. Okay, so let's also allow this router to always take it must always take this role of being an active router whenever it is up. So if we shut both of the routers down, we are expecting to always prefer this router as our active router. That what we need to set the preemption, not the priority, preemption. Okay, so by typing this command, we are telling the router that whenever you go down, by any chance when you come up, please can you become a active router. Okay, so now our configuration has been done. Now let's do it on this side. Remember, this is version 1, hence I didn't type any, or I didn't specify any version on our configuration to specify that this is actually version 2. So all I have to do is to do the same configuration that I have done on the other router. All I have to type is the interface gig 0/1, and then I want to say standby 1. I'll put it on the same group, standby 1. I want to actually leave the priority as it is, but I want to set the IP address of that visual router, which is 10.10.1. Okay, so both routers must have the same visual router, and then we actually need to leave the priority value as it is, as 100. By default the priority is 100. We're willing to see that as we actually show the configuration by the command to show standby. It will generate or print all of those information about the HSRP configured on each router. As you can see now, the role or the state of this router changed from nothing to standby. This is a standby router now, so it's a failover router. In a simple manner, we can just call it a failover router. If that router goes down, this one must be an active router to forward the traffic. Okay, now let's run the command do show. Let me just come out of this interface. Do show standby. This is gonna show me all of the details about the visual router or the HSRP state as a whole. It's gonna tell me that this states have changed for the first time, and we can see that this is the visual IP address that is configured on it. This is 10.10.1, which is this is the IP address. Alright, And also we can see that the active visual MAC address of this is this. Okay, so all HSRP version 1, they have this MAC address, which will be like this, and then it will represent the number of the group in the end, which is group 1. Alright, so this is the active visual MAC address. As all other interfaces, they have the MAC addresses. This visual IP also have its own MAC address because it's also an interface, but it's a visual interface. Now we have local visual MAC address, this one, and then we have the hold timers. Just like we said, they are by default set to 3 seconds. 3 seconds is actually quite long for the interface to be up, and then we have that I mean for the interface to actually change over, and then we have those hold timers set to 10 seconds, because within this specific time the changeover will actually take longer to actually change, so there are some packet that could be dropped, so which is why we have version 2, which allows us to change to milliseconds in a seamless manner. So we can change it to millisecond, and then we can actually see the changeover actually when it's happening. It actually doesn't take that long. Now let's go to the preemption is disabled on this interface. However, we can just enable it. Remember, we said that the preemption simply means that if the router goes down, as soon as it comes up, we want the router to be the active router. Alright, which is this configuration we have enabled on this other router, however not in this router. Alright, so the active router is being the IP address of the active router is actually being shown in here. As we can see that the active router have this interface of 10.10.10.2. If you look, we have this active router of 10.10.10.2. This is the router that we have been told about on this router, which is standby router, and then we can see that the priority of that router also is actually 150. Alright, and we have this router, the current router, which is a local router. It's a standby router itself. Alright, why is that so? Because the priority of this router is actually less than the priority of the active router, so it have the 100. It's a 100 priority. Now this is the group name. Let's go back to the other router now and see the difference between the two, and then we will see what happens when we shut down the interfaces and see the seamless changeover between the two when this router, which is currently standby, changes state to an active router, and then we will see what happens when we shut down this interface, all of those. Okay, we will also see when we try to push or set this priority higher than 150, and we will see that this router now will be a full active router as long as this one remains 150, and we set this one as maybe 160 or in above priority. Alright, let's go back to that router, which is router 1, and see what's gonna happen on this router when we try to print out the configuration of the HSRP by typing the command to show standby. This will show us the details about both active router and the standby. First thing that we're willing to see is the state of this router. As you can see, it is actually active, and we have these two state changes, and then we have this visual IP address that we're utilizing, which is 10.10.10.1, because actually we're willing to forward the traffic not to this local IP of 10.10.10.2. However, we want to forward the traffic to 10.10.10.1 as the visual IP. Right, so let's see what we have. Also, we have this MAC address of this HSRP MAC address. This is the MAC address that is used or utilized by the HSRP. So when the question comes, you'll always notice this by 0C and 07 with this following AC01 or anything, and then you'll see the group in the end. Okay, so this is the MAC address of what, of HSRP version 1. Okay, now let's go to the hello timers. By default, we didn't change any of those. We didn't change the whole timers as well, so everything is just in default in this case around hello timers and whole timers. Now the preemption is enabled on this router because remember what we said. We said as soon as it, but we're gonna see that we're gonna try to bring down the interface and see that router over here, which is a standby, goes up as the active router as soon as that interface goes down. But we're not gonna do any changes of the priority whatnot on that router. We're just gonna simple switch this interface back on and see the changes happen again when this router take over the role of being an active router as soon as we say no shutdown on that interface. Because of this command preemption enabled, that router will then take its role back to be an active router. Alright, so as you can see, the information that we have in here, it tells us about the standby router, which is 10.10.10.3, and the priority of that router or the configuration that is done on that standby HSRP on that router is actually 100. It's a default configuration of the priority. Alright, so this is the configured, as you can see, this is the configured priority on this one, so it was changed. Alright, so let's just minimize this. So this was actually changed. As you can see, we have 150 configured. This is the priority of this router over there. Now it's time for performing some tests between the two routers. Now all I have to do, I want to start by bringing down this interface so that you will see that there is nothing that will happen on an active router if I bring down this interface. So if I select the interface gigabit 0/1 and shut it down, it won't affect the other router on the other side because it's actually a standby router. Alright, so on the LAN segment, um, the devices, they actually, when they try to communicate with the internet, they're actually utilizing active router, which is router 1. Anyway, they are not aware about this router at the moment because they're using the active router to go to the visual IP. Alright, so as you can see, we have no changes on this router except for the OSPF that is configured on this router. Obviously the OSPF will be affected because there must be a true membership, there must be membership or adjacency being formed between the two interfaces. Okay, so once that interface is down, the OSPF send those hello timers, and then we have dead timers to see actually if the interface is still up or not. So until all of those expires, we can get this notification that actually the other router is actually down, the interface is actually down. But what I want you, or what I want us to look at, is the state or the status of the active router. Alright, the status of the active router is actually still the same. It didn't get affected by shutting down the interface on this side of the standby router. Okay, I'm just gonna hook it up again by typing the command no shutdown. Now we will see that adjacency forming again of the OSPF. Okay, let's wait for the interface to come up. Okay, as you can see, this is the adjacency forming between the two. I'm just gonna try to go down so that we will see the difference. Alright, now let's look at what happened to the let's look at what happened. As you can see, this router, as soon as it's up, I mean the interface up, it remember the role that it have, which is a standby router because of that priority that it has. it has a lower priority than this router. Now let's look at what happens if we shut down the interface on this side, which is gigabit 0/1. We're just gonna shut it down. Now what you will notice that this router over here, it will change from standby, and we will see some active state showing on this router, which is router 2. Now it will change its state to failover. This is how the failover actually occurs. Now let's shut down this interface and see what's going to happen. Well, what did you notice? We noticed that now this router is active as soon as we shut it down, that interface over there. Now we have this router as an active forwarding router, and we have noticed that the OSPF actually went down. We are expecting that to happen because of the interface have been detached on this gigabit 0/1. Alright, now let's go on this router, because we shut it down the interface, not the router itself, so we can still be able to see what is actually going on. Do show standby. Let's see what is actually happening now. The status of this is actually unknown. Why is that so? Because the interface is actually down. Unless if we try to modify the priority, and then we can be able to see that this is now a standby router. But for now the status is unknown because the interface is actually down. The interface is down, so the status is actually unknown. Okay, let's see what's gonna happen on this side. The status of this router is well known. It's known based on the standby configuration on it, because it can't see the other router, right? So this is the router that will have the configuration or the status that shows it as an active router. I'm just gonna do this and then do show standby. So you will see that now this router is actually an active route. So it's actually active, as you can see, and even though the preemption is disabled, but it is active. Alright, even though it has still a dead priority, it is active. Alright, it's an active route, but we cannot be able to tell if this is a standby, because it can't be a standby when this interface is actually down. Until that we hooked up this interface, then we can have this router as a standby router only if it has the lowest priority than this active router at the moment. But if we have this router as the router that has the highest priority and also have preemption configured on it, that simply means that this router will take over the role of that router which is currently have the active state. So this router will become active and that router go back to a standby, which is what we're gonna see right now, because we haven't actually lowered this configured priority on this router. So we're actually willing to see what is actually gonna happen right now as soon as I hook up that interface, which is gigabit 0/1. So if I say no shutdown, you will see that this router now will change its state and actually go to active router, because we have preemption and higher priority on this router over here. As soon as it comes up, the router itself will remember and say, okay, my role was this, and then let me carry on forwarding the traffic to that visual IP. What do you see? As you can see, the state have been changed now to an active, because this router remembers its role. Even though that interface was down and then it came up, this also have remembered its place. It knows that I was just a backup. Now the owner of the path has came back, so let's just let him lead the way. So as you can see, we have that router do show standby. So we have the route now went back to its state of being a forwarding route. Okay, and then let's go to that route over there, exit, and do show standby. So this router has changed its role to active again. It's no longer showing that priority or active router unknown, all of those. Okay, because it remembers its role of being an active router. Alright, so this is how actually the changeover actually occurs when you have the HSRP configured on routers, and you have that router have that priority as default of 100, and then you have the other one that you manually configure on the interface. Now let's see what happens if we try to change things around. Let's allow this router to be an active router and that to be a standby router. Okay, I'm just gonna try to bring this up, and then let's see. All we have to do is to select that interface again, which is interface gigabit 0 1, and I have to come in here and say I want to set the priority to be actually higher than 150. The priority of this, I'm just gonna say this is gonna be 151. Right, it's just gonna be high, and I want to set this as the preemption also by typing the command standby 1 preemption. Okay, so as soon as I've actually typed that, as you can see, I didn't have to wait. The route itself changed its states. Both routers, they changed the states, and this one took the role of being an active router as soon as I have actually configured this priority to be higher than the other one, which is this one. This router is now gonna be forever standby as long as this one is still available. Let's do show standby. Okay, let's exit from that interface and do show standby. As you can see, this router is now configured with manual configuration of that priority of 150, and we have preemption enabled, and we have this state as an active router, and you have that as the standby router. Do show standby. This will show me exactly what we have. We have that router as the standby router, so which means if I can try to shut down that interface gig 0/1 again, it won't have no effect on the active router. However, it will bring down the OSPF link state advertisement. So between those two routers there won't be some sort of adjacency between the two, because now one of the interface or one of the OSPF interface is actually down. So let me shut it down. Sorry, let me shut it down. Only the OSPF will go down. However, the way that the packet is being actually forwarded through the internet is actually the same. It still goes through from that PC and goes to the router and go to the internet and go to this active router over there. Right. So this is actually what is actually going on this HSRP configuration. Right. So let's actually try to we're gonna try to send some ping, and we're gonna try to verify all of those and see if we will see the changeover on the ICMP echo request and replies, and see how the packet is being actually dropped and the time it takes for the packet to be unreachable or for the destination to be unreachable, and then to be reachable again once the failover is being successful between the two routers, when the other one is inactive and when the other one is a standby. Okay, now as you can see, nothing changed. Let me bring it up and I'll shut down, and now we have this route is it's gonna go back up and then take its role to be a standby just now. In seconds we will see that it just gonna take its state of being a standby router, because this router now is the active router because of the higher priority that is manually configured on that interface, and also we have that preemption configured on that interface. Now let's see what's going to happen one last more time if we bring this interface down, which is 01. If we shut it down, these routers will just become active simultaneously. Alright, okay, let me just say no shutdown. It will be a standby. Soon it will go back to a standby. Alright, so let's give it some time. It's speaking and then it will be standby. Soon. Alright, let's give it some time. Let's give it some time. As you can see, it went back to be a standby router. So this is how actually this works. This is how it actually works. Let's see if we can ping to the internet on this router. Okay, first one is dropped, the second one is actually passing through. Let's see if we can ping from this interface, which is gigabits. Do ping from a specific source, which is gigabit 0/1. Okay, so we can ping to the internet from that specific source too. Alright, now let's go back to these hosts. These are just VPCs. They didn't actually use any operating system, so I can just come in here in one of them, and I would like to set an IP address of 10.10.10.5, and I will just say this is the subnet of 24, and I can set the default gateway as 10.10.1, and let's just wait for the configuration to finish up. And then once it's done, I can also set the DNS of that to be 8.8.8.8 to the internet, and then I want to actually show these IP settings. As you can see, we have the IP or the host IP address of 10.10.10.5, and we have the default gateway of 10.10.10.1. We have the DNS set, and forget about the MAC address. This is the network interface card MAC address. Alright, this is the default MTU size of any packet. So let's come in here on the ping. This is time for pinging. So we are willing to ping 10.10.10.1. As you can see, we can reach to the visual IP from that interface. The question is how to get there. If we run a trace to 10.10.10.10, remember this is just first hop redundancy protocol, but let's see what's going to happen if we try to go to there. So as you can see, this tells us that it went through this active router over there to reach to that interface. To reach to 10.10.10.1, it went to this active router because that is what we actually need. We want to see how to get through that visual router. It went through to the active router, but what if I bring it down? Now let's go back to that visual router. I want to bring down the interface. Sorry, I want to bring down this interface gig 0/1 so that this router will become a standby, will become unknown, and then this router will be an active router over there. So if I shut this down and that other router become active, this is what I want to see. I want to see it goes through 10.10.10.2 because now there is a changeover that has been occurring. So I want to run the same ping and see what's gonna happen. As you can see, we have 10.10.10.2, which is going through that router over there. It goes through that local IP of 10.10.10.2. Okay, this is what is going on. So just gonna pause this a bit. Yeah, so basically the concept is just the same. So as you can see, we're trying to trace to the 10.10.10, which is the visual IP, and then this is the hop that we actually see, 10.10.10.2. This is a first hop redundancy protocol, remember. So we go to 10.10.2 when we try to reach out to 10.10.10.1. Why is that? Because this router is an active router now. Let's see again what's gonna happen. Maybe this time around, let's see if I run the continuous ping. I'm just gonna try to ping 10.10.10.1, and then I'll just run the continuous ping so that we'll see how long does it take now to actually change. So I'm just gonna bring this interface up, no shut down. So let's see now the packet that will be dropped as soon as I do that. As you can see, we are willing to see, if you look at the sequence, the number of sequence here, which we have on 28, we have 29, we have 30. Okay, it looks like as yet we didn't actually lose uh, any packet as yet. Okay, so it's just a seamless change over, as you can see. Okay, sequence is still the same. Let me just shut it down again. As you can see, I've shut it down. The interface was shut down, but there is no packet that was dropped. Alright, we can still ping even when that interface is actually down, so it goes to the other interface. In this case, this is the interface. Alright, so let's hook it up again, no shut down. As you can see, we actually dropped one packet this time around. This is the packet that was dropped when the changeover was actually happening. But we can avoid this by actually minimizing the hello timers and the hold timers. Or we can increment, yes, we can minimize it in milliseconds, because currently it's on seconds. Right, so we just gonna be doing that when we actually configuring something called HSRP version 2. There is no much huge of a change. It's just that we need to specify the version that we are actually configuring, and then the visual MAC address will also change. It won't be the same as the other one, and the broadcasting IP address message is actually no longer that 224.0.0.2. It's actually 224.0.0.102. Right, something else also, as you can see, what if this interface is actually down, or what if that interface is actually down? Why would we want to actually forward traffic to the router when that interface is actually down? And why would we want to forward the traffic towards that side if that interface is actually down? So we'll need to configure something called track, so that we will track the interface as the status goes down or it changes. We can decrement the value of that priority on that router, so that this router will change its state from active and become inactive, so that this one will become active. Alright, so this will be standby. Sorry, as soon as we decrement the value of the priority, this will be standby, and then this one will be active based on the tracking, or the tracking of the interface, that if that interface changes its state, if this interface changes its state. So if this interface, which is gigabit 0/0, change its state, we want to actually decrement the value of the priority on that router, so that this local segment will actually know not to forward the traffic towards that path. It must rather go to the other side. So this is what we're going to be talking about based on HSRP version 2 on an upcoming video. I hope this video was so informative to you. Let's meet on an upcoming video. Okay.